Chapter 8, literal equations. We've worked with equations here the past 4 or 5 days. So you're going to apply the same rules, same concepts, only we're working with literal equations. A literal equation is a formula equation that involves several variables. Okay. Previous equations, normally we were solving for x or n and you were getting a numerical value. Today you will not get that one straightforward numerical answer such as 4. You're actually going to express your answer as an equation basically. So example 1, it says solve the following literal equations for the indicated variable. Here's the formula that they're given. A equals B times H. Actually, that is the formula for area equals base times height. You are going to solve for H. So you need to get H alone. So in order to get H alone, you need to follow those same thought process, techniques, steps that we have when we solve the equation. So in order to get H alone, we need to get rid of B. B is on that side. B is multiplying into H. Therefore, we need to divide by B to get rid of B. Now when you divide by B, your B's would cancel out, leaving you with H. On the left hand side, you're left with A divided by B. You can't do that anymore. You can't simplify it anymore. So your answer here is H equals A divided by B. Example 2, D equals R times T. That is the formula for distance equals rate times time. You need to get R by itself. R is on the right hand side of the equation, therefore we need to get rid of T. In order to get rid of T, T is multiplying into R, so we need to divide by T on both sides. When we do that, we get D divided by T will equal R. Literal equations. Example 3, need to get R by itself. Notice R is on the right hand side. Next to R we have 2 pi. 2 and pi are multiplying into R. So in order to get rid of that, we're going to need to divide by 2 pi. What you do to one side, again we do to the other side. 2 pi's on the right side. Those will cancel out, leaving you with R. And you're left with C divided by 2 pi. So now we have R alone, and we have our answer C. Oops, here. We have R equals C divided by pi. Example 4. A little bit different here in this problem. We need to get M by itself. Okay? M is right here. So we need to get rid of the 4, and we need to get rid of the minus 3n. Remember, you get rid of addition and subtraction first. So in order to get rid of minus 3n, we're going to add 3n to both sides. We drop down 4m. Our 3n's would cancel out. Now on the right side you have 8. Don't forget about my 8 up here. 8 plus 3n. Those are not like terms. You can't add them together, so you're going to leave it as 8 plus 3n. Now you need to go ahead and get m by itself. In order to get m by itself, 4 is multiplying into m. Therefore, we need to divide both sides by 4. What you do to one side, you do to the other. 4's will cancel out, and you're left with m equals 8 plus 3n, and this side is getting divided by 4. Alright, down here, example number 5. In example 5, we're going to solve for k. K is on the left side of my equation here. Notice on this side you're subtracting 2 from k, and also on that left side you're dividing the entire side by 5. 5 is dividing on this entire side here. So what we need to do is get rid of 5. Remember, when one side is totally getting multiplied or divided, take care of that. In order to get rid of the 5, which is being divided, we need to multiply by 5. And again, what you do to one side, you do to the other. So your 5's would cancel out. You're left with k minus 2 equals 11j times 5. Well, 11 times 5 is 55, and we would say 55j. K is still not by itself. We're solving for k. In order to get k alone, right now k is being subtracted by 2, so we need to get rid of the minus 2. So we need to add 2 to both sides. When you add 2 to both sides, k will drop down, your 2's will cancel out. 55j plus 2 can't happen, not like terms. So we leave it as 55j plus 2. 6. I'm going to have you go ahead and pause the video here. Give this one a shot. Look over your previous 5 examples. Check back in and we'll work through it together. So pause the video right now and work through it. Alright, now that we're back here, we need to get t alone. T is on the right hand side of that equation there. We need to get rid of the r, which is being multiplied into t, and we need to get rid of the positive 4. Get rid of addition and subtraction first. So I'm going to minus 4 from both sides. When I minus 4 from both sides, on the left side, I can do this operation, 28 take away 4. That is 24. Those are like terms. Left with tr. Get t alone. Well, r is multiplying into t, so I need to divide by r to both sides. And r's would cancel out. I'm left with t equals 24r. Alright, we're on the home stretch here. Example 7 and 8. Example 7 is a little bit different. You're going to get used to solving problems that deal with x and y here, especially when we get into chapter 19. Right now, in example number 7, you're going to get y by itself. Y is on the left-hand side of the equation. Okay? What is 2/3 doing to y? Well, negative 2/3 there is multiplying into y. So we need to get rid of x. X is positive. In order to get rid of positive x, we need to subtract x from both sides. And we get negative 2/3 y equals 12 minus x. Okay, next step is to get y alone. Well, in order to get y alone here, we need to get rid of negative 2/3. Negative 2/3 is multiplying into y, so we need to divide both sides by negative 2/3. Divide by negative 2/3. And we get y equals, this says 12 minus x all over negative 2/3. Now, you cannot leave your answer like this. Reason why is you have a fraction as a denominator. So you cannot have a fraction in the denominator there. We don't write a fraction as, this is a fraction here, 3/2. We don't write it as 1 over 3/2. That's not a fraction. So you actually need to carry out the operation. So I'm going to say no fraction, no frac as denominator. So we need to carry out the operation here. And what's happening is you're going to take y equals. Okay? This entire side is getting divided, right? So what you're going to do in your calculator is actually take 12 and divide it by negative 2/3. So in your calculator, put in 12 divided by negative 2/3, and you would get negative 18. So you actually solved it. Now, what you need to go ahead and do is take your x here. Your x really has a coefficient of 1. So you're going to take negative 1 and divide it by negative 2/3. Okay, so you've taken it into both. That fraction bar is telling you that you need to divide into 12 and the negative 1. So in your calculator, put in negative 1 divided by negative 2/3, and you would wind up with a positive 3/2, and then don't forget your x. This is our answer here in question 7. If you write it like this, it is incorrect. Do not have a fraction as a denominator. I'm going to backtrack here. I'm just going to show you one of the examples. Look at example 4. Notice how you can leave the problem like this because this number here is not a fraction. If it's not a fraction, you can leave this long fraction bar over 4. That is totally fine. But as soon as you wind up with the denominator, a fraction, you need to get rid of that fraction. All right. Example 8. Go ahead, pause the video here. I want you to work through this one on your own as well. Solve for Q, check back in. first step, you should have added 8 to both sides. Following that, you need to get q by itself, so we need to divide by a on both sides. And we get our a's cancel out, and we get q equals 31 over a. This concludes the lesson, literal equations, in Chapter 8.